Yes, hello friends, welcome to BISP Solutions. And BISP Solutions is a tech company, provides technological solutions across the world. Now, in our today's boot camp, today we are going to see capturing of image. Now, see, we have seen how cameras and how machine learning is made capable of identifying the image, whether it's a dog or a cat image, right? Secondly, the machine learning is made capable enough to read the sentence, right? Now we are going one step ahead, that is capturing the image. Now exactly what is the capturing the image? This is a part of recurrent neural network, right? Now capturing the image means exactly what? For example, if I give you one image, right? If I show you this image, now what will you do? You will see a dog, and it looks quite happy, and behind the dog you will see a ocean, right? So you have seen, and with your intelligence you have written it something like this. But at least here we need a human help, right? But what if I say that this task can be done by an AI enabled camera also? That camera will tell you exactly what is going on. For example, if the same image is given to a camera, and that camera the AI image, immediately that image is captured and it is fed to the machine, and that machine will tell that okay, this is a dog and standing happy in a ocean or in a water. Now take one step ahead. For example, there is a bank, right? Now in a bank, suppose if we deploy a human being that keep an eye in each and every person, it would be very difficult for him, because at least he will go for some refreshment. Now he can't keep an eye on each and every person. For that purpose, if just imagine what if the camera is mounted there, and that camera is taking continuously images, and those images are processed, and on the basis of those snapshots the machine is taking the decision. And in the middle of that image, if the machine says that a person sitting quiet without doing any action, neither he is communicating with anyone, neither he is talking with anyone, now this is something suspicious. So machine learning or AI is made capable enough to work like a human. For example, if you are sitting in a bank, and if a person is seeing everywhere, and then he come to know okay, this person is not talking to anyone, he is just clicking the images of the bank, that is called something suspicious. But this thing can be done with the help of AI enabled camera. What it does, it will take continuous images, and then it will analyze every photo of the room, and then on the base, suppose a lady is sitting with his child, so that camera RNN programming will identify okay, a lady is sitting with its child, right, with her child. Now we can feed some sentences that shows some suspicious, something fishy. For example, person sitting alone without talking to anybody, or a person taking images without any reason. And on the basis of that, the camera or the machine is capable enough to identify the suspicious people without any human presence. So that is the power of AI, right? So what exactly I am going to tell you, that capturing of image means the camera or the machine is capable enough to write a sentence of whatever it sees, whatever is feed, whatever the feed coming in that camera. For example, if this image is given to the machine, and then machine says that okay, this is a dog standing alone. Similarly, you can see here a person riding a horse on a background. That means there is nothing suspicious in it. But as soon as the statement received by the intelligence services that a person daily comes to the bank and not communicating with anybody, just clicking the images, immediately the intelligence services will be alert and immediately they will take action. So this is called AI collaboration with the intelligence department, and AI is helping the police or intelligence department. That means without deploying any human being, the intelligence department gets information just because of the capability of writing the caption based on the image. That's it, right? So this is what the power of AI. Similarly, now this thing is done with now let me show you one or two more scenarios also. For example, if you see on a traffic signal light, the camera is the AI camera is capable enough to identify all those people, those who are not wearing helmet. Immediately it will take the image of those people, and then with the help of RNN and CNN, it will take out the nameplate number, and immediately the list is sent to the RTO department. That RTO department immediately take action on them, and or one step ahead, we say all the immediate receipt and challans, they go penalty email, they are automatically sent to the concerned people. So this is how one more scenario is there. Third scenario, in the airport area, right, in the where the people sit for waiting for their flight, there also you can install these AI enabled cameras. Continuously the camera takes images and feed it to the machine, and that highly enhanced program will decide that in which area we have seen suspicious activity. That means all in all, the moral of the story is that AI is now capable to find out which thing is suspicious and which thing is normal. That's it, right? So this is how we work on it. Now this thing is done, see, writing the caption based on images done with the help of two things. Now you can see here one more before starting that I will show you this. Now this image, if this image is fed to the camera or the machine, so what the caption will come: a group of people shopping at an outdoor market, there are many vegetables at the fruit stand. None of these lines are suspicious. But imagine if this line is written, suppose if the photo is something like a person is clicking the photo of some government buildings, and this photo, or the what will be the caption: a person is clicking image of some government building which is prohibited. Now this thing is suspicious, and immediately this, as soon as this caption immediately this caption is sent to the police or the intelligence department, and in this way the things can be the crime can be stopped. So that is what I mean to say. Now here you can see again one more time, we will go here. This thing can be achieved with the help of two things. One is language generating RNN. RNN works on text and CNN works on image, right? CNN, convolutional neural network. I recommend you to watch my previous video. In that previous video I have explained CNN also, image capturing, right? So if you search a little on YouTube, you will get that video of CNN. Now see here, CNN works on image and RNN works on text, right? Now see here again, generating sentence from images. How it generates? Now suppose if you present this image in front of me, so since a human can easily see this image, and easily that a person can say that okay, a man is sitting on the horse and he is riding on a ground. But the machine language, what CNN will do, CNN first will it will identify which animal is this, then it will identify someone is sitting on the horse, and then it will identify that okay, in the background there is a ground. So based on that, and a person is riding the horse. Look at this, you can see here, if I zoom in, horse, ride, field. Look at this, right? Horse, ride and field. So in this way CNN identifies, okay, first of all the horse is there and the rider is there and it is riding on a field. Similarly, so this is how it is done. With two things are working behind this. One is the CNN, that is convolutional neural network, that works on images, and language generating RNN, recurrent neural network, that works on text, right? Now let's come here one more. Yes, here. Now see here, when this image is given to the machine, so what will happen when this image is given to the machine will first, CNN will come into action, that okay, this is a dog puppy, right? And now this puppy is playing with the football, and in the background it identifies, okay, it's a ground or a lawn, anything. So this is called pre-trained on ImageNet. So previously whatever the training is given to CNN, based on that the CNN gives you the image. And now trainable layer in MLP, right? So multi-layer perceptron, with the help of this, immediately this is LSTM, means is playing with football in a lawn, right? Here is dog, and then here you will see the grass also, because this CNN is feeding in from the background, and based on that background the sentence is generating. For example, if I type I am on the way, will call you. Now will call you, either two statements are there, once I reach home or once I reach office, right? Suppose I am typing on my keypad that right now I am driving, I will call you once. Now after once what? Once I reach home or once I reach office. This here the image is given to the machine, and then CNN identifies, okay, dog is there, football is there, dog is playing with football is there. Now the grass is also there, that means it's a playground or it's a lawn, anything, right? So based on these images the sentences are generated. A dog is playing with football on a ground, right? So that is what this both CNN and RNN works together, right? So that is called, and once they work together, that is called, they generate the captions of the image. Clear? And this thing can be used in many cases. For example, one satellite image is there, right? Suppose now satellite image is there. Inside that satellite image, whatever, suppose few persons are collected or gathered in one isolated area. So for what purpose they are doing? So the intelligence services, they will take decision on that. But when we make the camera capable enough to do this, to think on this, and to write the captions, so based on these captions it would be easy for the intelligence services that to identify the terrorist and the common man, right? So that is why this CNN and RNN is mostly useful for intelligence services, police services, all these, to find whether something is suspicious. Clear? Okay, now let's see here encoder CNN. Now encoder CNN means exactly what? See, during the work of this captioning, right, our main target is to see the image and write a sentence, and based on those sentence immediately the action is taken. For example, let me give you one example, very simple example. Suppose if I You also might have experienced in Google. For example, suppose if I feed some few words in a machine like communication without and idle, right? Nothing, bomb, etc. Not bomb. If you see the Google, when you type any suspicious word on Google search, immediately it gives you the alert, right? Similarly, if I type all these things, right, without doing anything or doing nothing, if these keywords come in the sequence, for example, in a bank, let's take an example. In a bank, a camera is constantly capturing the images and feeding to the RNN enabled machine. And suppose if a sentence comes like snapshot, right, one more keyword, snapshot, right? Now suppose if the sentence caption, look at the caption, a person taking snapshot of bank, doing nothing, sitting quiet, right? Now a person taking snapshot of bank, doing nothing, sitting quiet, when he is not having any work there, then why this person is doing here? So these type of sentences are called suspicious sentences, and these sentences are shown are sent to the directly to the intelligence department, and then immediately they take action. So we can stop the crime with help of using these CNN and RNN, right? Okay, now see here, encoder CNN. Now what is this encoder CNN? This encoder CNN that I used was a pre-trained ResNet 50 architecture, right? It's an architecture in which encoding and decoding is done, right? Let me show you this. Look at this. How this ResNet architecture is done. What is this ResNet architecture? Exactly, ResNet architecture we have already discussed on our previous videos, that first in convolutional plus ReLU, it is an activation method, right? Then max pooling, buffering of the pixels, then fully connected plus ReLU are used to capture the image and write a snapshot, write a caption on that, right? So that is why it is ResNet architecture, how it works. Similarly, if you see here, what is convolutional neural network? Convolutional neural network is a type of deep learning neural network architecture commonly used in computer vision. Now see here, if I zoom in, just a second, let me zoom in. Now see here, this convolutional neural network, what it does, it will take some small image, small caption, right, pixel, and that pixel is taken out and then it is processed. So with the help of convolutional plus ReLU plus max pooling, right, and with the help of this you send, these are the inputs, right, these blue colored circles. After that you will see here, this is the first layer of hidden layer, second hidden layer, and the work of this hidden layer is to just identify exactly what image you are seeing, right? And in this way, what image you are seeing, and finally after so many iterations it gives you a bird. Okay, so this is how it work. Now see here, one more, let me zoom out. Convolutional layer means exactly, see, it captures the whole image, right, but it captures a small part of every pixel, or you can say that it divides the complete picture into the different parts, and then it creates a layer, right? For example, if you see, the convolutional layer is used to extract features from the input image. Okay, now let's see this relief layer. This is called the relief layer. Now in this relief layer, it is also a relief is an activation function. Okay, so we have already discussed how relief function works, right? So this is how the relief function works. And now again, one more thing, that is pooling layer. So these layers make the programming more powerful, that the camera is capable in reading the images and writing the captions. First of all, convolutional layer is decided first, right? After that, relief layer from the from the main image, right? And then after that, you will see the pooling layer. The pooling layer is used to reduce the size of an image while maintaining the most important features. The most common type of pooling layer, and the max and the average. So we divide the image into small parts. For example, in practically also, if you cut an image and just remove the strips, every alternate strip, right? For example, this is an image, right? Let me give you one example. This image, if you vertically cut this image into the strips, and every even strip if you remove, so you will see at the end, you will see two images of same bird. You can do the practical also. Cut this image into horizontal strips, one by one, into 100 strips. Now separate all the even number strips, that means for second strip, then the fourth strip, and arrange them in the same sequence. Now you will see at the end of the story that you will see you have the two images ready, right? You do the practical and let me know exactly how it looks. Okay, now this is called where is it? Yeah, where is pooling layer. Same thing is there. We need to use this image to reduce the size of the image, and the same process it follows. Look at this, 30 0 2 0. 30 is the maximum number, 20 12 12 8. 20 is the maximum number. Maximum pooling, average pooling for this particular block, right? So let me do it in front of you. Okay, this is the 20. Okay, now average. Look at this average pooling. Max pooling is something like this, the maximum number it picks, right? And average pooling means this 8. How this 8 comes? 30 plus 2, that is 32. Divide by 4, that is 4 8s are 32. Similarly, 12 24. 24 plus 20, that is 44. 44 plus 8, that is 52. 52 divided by 4, that is 13. So in this way average is taken out, right? So let me show you practically also. Look at this, 12 plus 20 plus a 8 plus 12 plus divide by 4. That is 1 3. Look at this, right? So this is called average pooling, and in this, with the help of this average pooling, it reduces the size of the image. Okay, so this is how it is done. Then we come to full connected layers. Now what is this full connected layers? Full connected layers means, for example, again the same example I am giving you. A full connected layer is a convolutional neural network, connects every neuron in one layer to every neuron in the next layer. For example, suppose at a first glance I have seen an image, but based on that image I need to take several decisions, and then only we can move ahead. So these are called first layer, first hidden layer. This is called the second hidden layer. So on this first and second hidden layer, everything is decided. Now see here, what is decoder RNN? Actually, decoder RNN means, see, in this complete process of capturing the image, writing down the line number, after this, first of all, the data is encoded and the data is decoded. Okay, now decoder RNN, you see the job of the RNN. Just give me a second. Okay, now see here, the job of the RNN is to decode the process vectors. Now see, recurrent neural network. What is this recurrent? Recurrent neural network is the same thing, but it works on the text, and this text, you see, it is having a memory also, short-term memory also. With the help of this, it stores the last data, and then it works like, you see here, it's a loop, right? And here is the hidden layers. There could be many hidden layers. Now it is up to you that how you use it. And this is how the recurrent neural network works. First of all, in the first stage, now see here, first of all, you will see this is a anti-clockwise it is going. It is the what we say, the starting image reading, and it get trained based on the exercise. Every time what we provide this machine, it is fully trained one by one, right? So now this is how and the process is the same. Okay, now how whatever they are they want to extract, we can extract it, and we can write down the narration also with the help of this RNN only. Now what is this LSTM, long short memory, long short term memory? Okay, what is this LSTM, long short term memory? Is a recurrent neural network architecture widely used to deep learning. It excels at capturing long term dependencies, making it deal for sequence production tasks. So in this way, if you see this is a complete internal mechanism of how it works. So we are just using the application of those images, right? This is done in the back end. Okay, now if you see here, same thing, LSTM, how the LSTM works, right? So So how the machine works? So that is what here you see. Long short term memory. Long short term memory means, for example, it's a recurrent neural network and architecture widely and in deep learning. Okay, so now this is how it works. Long short term memories, right? And this is the mechanism, back-end mechanism, right? So we are not concerned with that. We are concerned with the concept, exactly how it works, right? And secondly, I have already provided you the scenario, or we can say the use cases. Right, we will see the use cases also. In our next video also we will see something related to practical part, right? CNN and RNN, right? So this is how it works. First of all, machine will check it out, machine will identify okay what it is, and based on that measurements. Okay, so guys, my recommendation to you is to watch this video one time, two time, right? Watch this video twice, thrice, and then you will come to know exactly how it is done. And then if you have any doubt, next meeting we will resolve your doubt, and in the next meeting only we will have a word with the student, right? So now if you see, in our next meeting we will see something new topic. So till then you watch this, and if you face any difficulty, right, so you can put down in the comment box. I will definitely reply your solve your query, right? So guys, today we are concluding here only, but in our next session we will see something new with practical. And if those who are new to this channel, please like and subscribe my channel. Okay guys, thanks for attending the bootcamp.